Professor Amy J. Cole was a professor at the University of Washington in Information School and the Paul G. Allen School of Computer Science and Engineering. So before I introduce her, I'll tell you a little bit about the background. A couple of years back, a colleague of ours, Sébastien Moster, who's now at Western University in Ontario, he sent an email with the keynote given by Amy, which talked about, I don't remember from which conference, but it talked about bias in requirement engineering. And it was very striking and very enlightening. So Ruslan and I, so we have been chasing Amy for about 2 or 3 years.
Exactly.
To invite her to give a seminar, to give a talk at the Lattes seminar. And so finally all the stars lined up and we're here today and we're very happy to have you deliver the talk. So it's a much bigger challenge to talk about justice in programming languages. I'm like, what? Programming language instruction? So we're very eager to hear about that. This is going to be exciting. But Amy directs the Code and Cognition Lab, where she and her students study computing education, human-computer interaction, and humanities, individual and collective struggle to understand computing and to harness it for creativity, equity, and justice. With her collaborators, she has invented many tools and programming languages to support debugging, program understanding, reuse, and learning. Founded and sold a venture-backed startup. I personally was very impressed by that, and I actually looked it up. And sounds like very cool products. I have lots of admiration for any academic who actually does have real impact in the real world, and that's one of them. Developed numerous ways to weave equity and justice into computing education, pedagogy, culture, and technology. Impacted local, state, and federal K-12 CS education through community organizing and advocacy. Her work spans more than 130 peer-reviewed publications, 19 Best Paper Awards, 4 Most Influential Papers. She's an ACM Distinguished Member of CKI Academy, for her substantial contributions to the field of human-computer interactions. All of this is music to my friend Julienne's ears, who's in. So she got the PhD at the Human-Computer Interaction Institute at Carnegie Mellon under the supervision of Brad Myers, whom I mentioned at the beginning. I went to your page to see. So the research page says, I study our individual and collective struggle to understand computing and harness it for play, power, equity, and justice. And I love the way that it's presented discoveries. Justice-focused CS education is empowering, but requires student trust and agency. That's one of the discoveries. CS assessments aren't fair, but it's very hard to know how and why. That's something we deal with every day, et cetera, et cetera. So I seriously invite you to take a look at the research page. It's impressive and it's very enlightening. So, oh my God, I have been talking for too long. So with that very long introduction, you take it away.
Thank you so much. And thanks to everybody for joining in person and online. And I hope everybody in person is enjoying their pizza. I wish I had pizza right now. It'd be a great way to start the talk. So justice and programming languages, that's a question and an intersection that we don't usually talk about. So I'm going to hope today to share some of the ways that those two intersect and give you a sense of why I think they're fundamentally related to each other in ways that we don't usually think about. So I'll start off just by sharing a little bit about my story. So I began my career by inventing a lot of interactive developer tools, trying to make programming more productive with new kinds of editors and debuggers and verification tools. Some of these were taken up by industry, some of them were taken up by other researchers, and I think they had a lot of impact. And probably made a lot of developers work a little bit faster. So I think that's a win. And that's, for many of us in software engineering, one of the goals that we've always had, is making software more successfully and more productively. But I set that work aside for some good reasons, and sometimes some personal reasons. Back in 2010, I was just doing a startup and eventually leaving that startup a few years later. And I saw a world that was increasingly computational, but also one that was more complex and centralized and even colonial than it ever was before, eating the world in these powerful ways and even oppressive ways. And those trends have really continued in the past 15 years. And so I wanted to help create a different world where there was a more critical computing literacy that was available to everybody and available equitably to everybody, so that everybody could really understand how it was that big tech companies, for example, were centralizing control over the kinds of information that the public had, for example. And public education is really the biggest lever that we have. So I joined the global CS for All movement to try to help broaden participation and dismantle barriers to learning about computing, and try to address some of the inequities that result in so few people learning these ideas. And so I really went through a journey in this process. I started thinking about it in somewhat neoliberal terms, like most computer science does. We think about training computer science students to take FANG jobs. And I shifted a lot of my perspectives from that to one that was really more centered on justice. And so here are a few basic ideas about justice. Patricia Hill Collins, for example, often describes a matrix of oppression, all of the systems that entrench power hierarchies by erasing intersecting identities in the world. Computing and computing education, in my view, reinforces this matrix. It frames computing and learning as a tool for corporate profit, as opposed to a tool for liberation, for example. And so one way of thinking about justice is dismantling this matrix and trying to create new, more equitable systems that work for everybody, instead of just those that have dominant identities and social power in society. So that's one way you can think about justice broadly, outside the context of programming languages, but in the context of computing in the world. And so I've done a lot of things in this space to try to advance justice over the past 15 years. We have launched new teacher education programs that center justice in preparing secondary teachers to talk about computer science, not just in computer science classrooms, but in social studies, in language arts, in other subject areas. We've written books that talk about this and help support teacher education. We've invented teaching methods that do this. We've examined bias in assessments. We've studied the social norms and the fears that deter educators from teaching about computer science critically. We examined ways of looking at assumptions in software design too, and teaching about assumptions in the context of computer science. And that includes assumptions about ability, for example, but also assumptions about social resources that people have. So all of these projects have really moved in that one direction. And we've had some success in having them taken up. We've shaped state and federal policy in the United States. We've shaped curricula, learning technologies, teacher education pathways, and through that reached millions of youth through a lot of these changes, and hopefully in some small way are getting youth to think about computing, not just in optimistic terms, but also in critical terms, in the ways that computing is sometimes deployed in ways that ultimately do harm. And yet, despite all of that work, there is still one thing that stands in the way of a lot of this progress, and it is the tools of computing that make it impossible in some cases for people to participate in this learning. And I want to tell a story about that, just so that you understand what I mean by impossible. I was in South Seattle. This is a region that's just south of the city, in a math classroom last spring. Most of the students in South Seattle are refugees, because Seattle is a sanctuary city that invites a lot of refugees from all over the world to settle in the United States. Most were learning English. Many had disabilities, including dyslexia, blindness, low vision, motor impairments, some of them injuries from war. And the 25 kids in the classroom spoke a combined 17 different languages. And so imagine that classroom for a moment and what it means to teach any subject, let alone computer science. the teacher had completed some professional development for computer science and wanted to integrate computer science into her classroom and her algebra lessons in a culturally sustaining ways. And she had a lot of questions when we were talking. Questions like, what platforms would work for my blind, low vision, and motor impaired students? What would work for the 17 different languages in the classroom and for the English language learners? What platforms can center my students' own languages and cultures instead of Western American ones? And what platforms seriously engage math and computing, but aren't just incredibly boring to most students, especially the sixth graders that she was teaching? So imagine 13-year-olds being excited about any of these things. And there really is no answer. And that's because most of the educational programming languages and tools that we design are designed with a set of assumptions that exclude all of those classrooms and all of those youth. They assume that students can read English, that they can see, that they can use a mouse, that they're interested in computer science, and that they will persist when things get hard. Most of those things are not true for her students. And of course, they aren't really true for most students in the world. They're really only true for English-speaking, normatively abled youth who fall in love with computing itself. And that does not describe most youth in the world. And so none of these forms of ability, culture, language, and identity exclusion are really all that surprising. They are a direct consequence of the ableist, colonizing, and hegemonic decisions made by computer scientists from the 1960s to today that sometimes intentionally, sometimes unintentionally, center white, Western, ability normative ideas about who computer science is for in our programming languages and our tools. And you can even see it outside of programming tools, like let's say Zoom, for example. Why are captions off by default in Zoom when so many people who are deaf or hard of hearing need captions to participate in a meeting? These are the kinds of implicit defaults that we choose that aren't necessarily intended to be harmful, but the intent here doesn't really matter because the outcome is exclusion. And so the computing education research community is just starting to make progress on breaking some of these assumptions. Here are some examples. The Bootstrap project with Racket and Pirate programming languages has really deep integrations with algebra and some focus on accessibility, but it assumes English and makes little room for identity work and creativity. Scratch, who many of you might be familiar with, has become ubiquitous in K-12 schools. It does a great job centering expression and is localized in many languages, but because it requires use of a mouse, it isn't screen readable, and anybody that can't use a mouse and relies on a keyboard can't participate at all. Quorum was designed to be screen readable for people who are blind or low vision or dyslexic, and keyboard accessible, but it assumes English and decenters creativity and student culture. And the wonderful platform Hetty by my colleague Felina Hermans in the Netherlands embraces dozens of natural languages, even down at the syntax level, but really segregates languages. And so any bilingual students, for example, can't really bring all of their languages to play in one place. They really have to use languages one at a time. And so just begs this question, where are the creative coding platforms that celebrate the beauty of computing, but also disability justice and decolonization? And these are questions we don't usually ask about programming languages. So I tried to make one. I had a sabbatical last year and I had a lot of time. And so I decided to spend my time seeing what I could create. And not doing that in a vacuum, reading a lot, understanding a lot, talking to a lot of people to understand needs, but ultimately approaching this as just some time to make creatively and not in particular as a research project. And so I had a lot of ideas for programming languages that I hadn't had time to explore over the course of my career. This was a chance during sabbatical to explore them. I was also excited about typography and the new Noto font, which supports all of the world's languages that are supported by Unicode, and that was really exciting to me. And I decided to just make and not evaluate. And so this was going to be work that generated new questions and not necessarily answers. So I think you'll see that in what I share here. And so these were my 4 goals, and I want to walk through these as I illustrate some of the things that I invented. I wanted to be global, to celebrate the world's languages without centering English. I wanted to be accessible, to center ability diversity as a fact of human nature, and neurodiversity as the fact for how we think and perceive the world differently. I wanted to center playfulness. So embracing the silliness of adolescence and really thinking about those 12, 13, and 14-year-olds that we're designing for, and not the seriousness of computer science. And then lastly, I wanted to focus on simplicity and really take complexity and try to remove as much of it as possible. And so this is what I came up with. It's called Wordplay. It's a new programming language and platform, and it really is about thinking about Unicode as a palette for creative expression. And that's really the goal of the whole platform. So you'll see a lot of examples that I'll show in this presentation, and these are all made in Wordplay if you ever see anything animating on the screen, and I'll try to describe them as well. So let's start with global. Here you have some Japanese hiragana falling using a physics engine onto some invisible platform. This should be a platform where we embrace the world's languages and really think about what it means to not center English. And so there's a lot of things to do here. And the challenge, of course, is that most programming languages really are English all the way down the whole stack. English keywords, English grammar, English concepts, they aren't designed to be translated into other languages. And then programming languages often have no built-in support for translating their output even into other languages. Localization is something that's layered on later as an afterthought. This is not really an accident. It's the direct result of a kind of winner-take-all settler colonialism. English won, and so it dominates everything. If you take a justice-centered view on this, you might take a linguistic justice viewpoint and say that all languages are supported and none are privileged. And we try to operationalize this in Wordplay by essentially removing all English and all keywords from the language and only using symbols for syntax. And then we take all of the names that you might give in a computer program, documentation as well, and output, and we make sure that language tags on those names are always available and supported, and that you can actually have many names in many different languages for the same basic concept in a program. So here's some examples. Here are the symbols I chose. It's really interesting and challenging to choose symbols that don't have deeply situated cultural meaning. False, for example, the word in English might translate to lie or deception in other languages, which is not the same concept for Boolean values. So we chose these mathematical symbols from logic to help avoid cultural assumptions. So a sixth grader probably isn't going to know what these symbols mean at all. So we can layer on new meanings on top of them rather than having existing meanings from natural language keywords. All of the other symbols in the programming language are names. So infix operators can be any non-emoji character in the symbols category of Unicode tables. And names can be any sequence of non-reserved, non-operator characters, including emojis too. And so all of the world's languages are supported in this. This includes numbers. And so we can take numbers from all of the different scripts in the world and combine them together and do arithmetic on them, like adding 1 to the Japanese number 2 and dividing it by the Roman numeral number 3 and checking whether it's greater than the Greek pi. All of these different number systems and numerals can be mixed together regardless of what languages somebody might read or write. And then we can have translations. So here there's documentation in English and Spanish and variable names in English and Spanish. And you can use either of them to refer to them too and very quickly reskin a program in different languages depending on what language somebody wants to read it in. Here are some simple data structures. There's a nothing value, lists, sets, maps, aggregate data structures. And they're very typographically spare. They don't use any culturally bound keywords to declare any of these things. And then there's a very simple functional grammar too. And so it really blends together a lot of different languages ideas. Smalltalk's love of objects, Lisp's love of parentheses. If anybody knows APL anymore, its love of symbols, and functional programming's love of expressions, all while avoiding any natural language grammar mimicry to avoid any privileging any particular natural language. So here is the factorial function, for example, really simple spare declaration, all relatively symbolic, and not really using any keywords from any other languages. And so what all of this adds up to is features like instant localization, and not only of code, but of output too. So here I'm going to start a video that shows a word guessing game called What Word, and it's currently rendered in English, but you'll see when we go to the language panel and we choose Spanish instead, it's rendered in Spanish. And if we were to choose, let's say, Arabic as well, we can see it in Arabic and rendered as the exact same program, but even choose multiple languages and have it be rendered in both at that same time. And not only is the program changing, but the program output is changing as well as all of the documentation. And so what this enables is situations like a teacher who is fluent in English teaching students who are fluent in Spanish and being able to very fluidly move between those languages or even see programs in both languages at the same time. And so this raises a lot of questions about being global. What's gained and lost with this kind of deep localization of an entire programming system? What are the opportunities for students translanguaging, where they're using their different language resources to learn and to facilitate teaching across multiple languages? What can we teach about localization itself by building concepts of localization directly into a programming language? And how do English learners' perceptions of computer science change when they see some concepts in non-English languages? And then, of course, we have to ask, is this justice? Well, kind of in a really mundane way, right? It feels like the least we might do in programming languages to support this. There's still this whole mountain of translation labor to do. Machine translation isn't particularly good on sparse data like this, and so it doesn't really solve that problem. And it leaves intact all of these broader forces that privilege English and Western civilization, including those in the very machine translation tools that might help address those gaps, since there are so many linguistic biases in those machine translation techniques that privilege English. So that's global. Let's talk about playfulness. Here you're seeing some raining cats. I like cats, and so there aren't any dogs in this one. What does it mean to do that in a programming language and do it at the language level and not just at the application level? Well, here's the central problem. Programming languages outgroup. This is an idea from social psychology about people creating social groups that include and exclude based on different identities. And community is often one of the first things that learners see when they're experiencing a new programming language. It gets signaled in tooling and documentation and learning materials, in the language syntax itself, the editors, and it conveys a kind of group membership in ways about who belongs in particular communities and who does not. And that's not an accident. Dominant groups in CS often uphold an epistemic hegemony that privileges Western rationality and rejects subjectivity. And this becomes really clear when you visit any programming language's webpage, for example, about how they communicate what computing is and what programming languages are. And so a justice perspective on this might look at epistemic justice, and that might mean actively resisting the idea that programming languages and their designers are the sole sources of authority, truth, and objectivity in computing. Wordplay tries to operationalize this by anthropomorphizing computing concepts through a kind of lore similar to that you might find in games, building a world in which computing concepts interact and have conflict and collaborate and are not necessarily the sole truth of what computing is. And so the premise here in Wordplay is that there's a community of characters, and every single Unicode glyph is one of the characters in this universe. And they like to put on performances, and they like to collaborate with choreographers, the programmers who are writing programs with them. Some of those characters like to be on stage as output. Some of them like to choreograph as code. Some of them like to do other types of things around style, controlling lighting. And then every character in that universe has a personality, but also a positionality, something that situates them in the world and biases and limits their perspectives. So here, for example, this Dutch florin, this F symbol, this is the one that represents a program and also functions. And so here, F is excited about planning a performance with the character and says, "I'm so excited to put on a show with you. Where should we start?" Some characters, though, really convey their epistemic struggles with computational purposes that they might hold. And so these are conveyed in diaries, documentation, where language concepts project their purpose and their values and their concerns. So here, the conditional statement, which is represented by the question mark, wrestles existentially with binary decision-making and their skepticism of dichotomous truth values. So I'll read this. It says, "Do you ever think about how we decide? I think about that a lot. So many decisions in life can be so complicated. Sometimes I feel a lot of pressure to decide since I'm the only one in this universe who gets to decide. I get overwhelmed, and so I've tried to simplify things. Boolean helps me reduce everything to two options. I know that decisions are rarely this simple, but breaking the world down into two options makes things easier for me. And then you can go to Boolean and see that Boolean really only thinks in these two truth values and has no other ways of reasoning about things. So this is a kind of critical way of examining what is Boolean logic, what are Boolean values, and why do they not faithfully represent all of the kinds of decisions in the world that we might want to make. Another example is errors. So wordplay frames errors as conflicts between different characters in the world, as opposed to errors or mistakes that a learner has made. And that's really critical because inherently that's what errors in programming languages are. They're just disagreements between different parts of a program that can't be resolved to be unambiguous. And so framing them as conflicts decenters the learner as the source of the mistake, and really says that this is just about a limitation of the language itself. We can't know what you mean because there's constraints that can't be satisfied at the same time. And so this question of playfulness raises a lot of other issues. What effect does anthropomorphization, for example, have on learning and self-efficacy and theory of intelligence? How could we write some of the lore to align with different cultural values and ideas, especially in different locales where we shift into other languages? And what is the effect of silliness on how youth perceive computer science as a discipline? How does that change their ideas and attitudes towards it? Of course, we have to ask, is this justice? Well, it's certainly a small kind of resistance. It's one programming language amongst thousands, and perhaps the only one that explicitly questions the epistemic claims of computing inside the medium itself. But justice might mean that all programming languages and their communities do this work and center humility about computing and its limitations, and even advocate for refusal and not building and maybe not using programming languages to do every kind of problem in the world. And so I view this as a really small step towards justice, and really the much larger ones are ones that would re-examine everything. Let's talk about accessibility. This is a space that a lot of computing has not reckoned with, and we often don't because we don't think about the people who are not in our learning spaces. When we teach computer science, it is rare for us to be aware that students have disabilities. It is rare for them to disclose it. And for the ones that might be really visible disabilities, like blindness or using a wheelchair, they often aren't in computer science because they know that if they were to study in a computer science learning context, they would not be supported. They would not be able to read the slides. They would not be able to understand any of the materials that we have because those materials are not accessible. And so radically examining accessibility means really embracing the fact that people with disabilities exist, and we have to redesign our teaching, our learning, and our tools to engage them. So the fundamental problem here is that with programming languages in particular, there are a whole bunch of assumptions they make about ability that only work for a subset of humanity. If you require, for example, everybody to use a mouse, like in Scratch, you don't get people who can't use a mouse. If you require everybody to use a keyboard, like in a lot of textual programming languages used by professionals, and you can't use a keyboard because you can only do speech input, for example, then you don't get people who rely on speech input. If you require vision to be able to process all of the things that might happen in an IDE or a command line, you don't get people who are blind or low vision, and so on. And none of this, again, is an accident, right? Programming languages are just one example of the broader ignorance and disregard for disability in computing and the broader world. And it's one now that is self-reinforcing because our tools end up categorically excluding people, and so they cannot participate in making better tools for the world. So the idea for wordplay here is a kind of disability justice, where there's agency for people with disabilities to shape the programming languages and tools that we have. And in wordplay, this might mean not only their participation in designing it, but flexibility, multiple modalities for input and output when reading and writing and evaluating code, but also control over time and color and other details that are typically under the control of a computer or a runtime or a designer. So here are some examples. I worked on a hybrid text and block-based editor that where you can use a keyboard and or a mouse and drag and drop and menus to do editing. So here's an example. Here's a little program that takes a sentence and it's going to divide up that sentence by some spaces, and then find all of the words in that have the word justice, and then return a list of them. So there's 2 of those phrases that have the word justice in them. That is the text-based editing. But you can also do this through drag and drop. And so there's a little palette of all of the programming languages constructs, and we can construct a filter expression here, and then go through and find other parts of this expression that we want to build, to take a statement and divide it up. It's a little bit slower, but it doesn't require recall of the whole programming language's semantics. So there's our divide statement. We're going to have this delimiter of a space, and then finally, the filter is going to be an equality statement on that last expression. And so we'll drag this has expression there. Choose the item, and then choose the word justice. And so we'll get the same program. So slower, but if you can't use a keyboard and want to use a mouse, or you don't know the language well yet and you want to scan and understand the program, this prevents segregation in classrooms so that anybody who has different abilities can participate. The editor also allows for both visual and audio navigation of program structure. So if you're sighted, you can read all of the program text here. But if you rely on a screen reader, we can go through and navigate the program in using a screen reader's audio text-to-speech.
Before evaluation close. Before. Dimension, degrees. Unit, number, evaluate, rainbow. Bind, color. Evaluate, cross-eyed grinning face with stuck-out tongue. Bind, rest, evaluate, speech bubble. Function. Evaluate, translate. Evaluation open, evaluation open. Property access, TBD. Evaluate, plus. Evaluate, globe showing Americas.
And so that's an example of really making code visible through sound instead of making it visible through sight. And then the same is true for output here. Any output that's rendered in a wordplay program is always screen readable by default. And so we can always describe what's happening on the scene and what's changing on the scene as well. So here you'll see a little maze game where somebody's navigating using the screen reader.
Movie clapboard, dim phrase. Right arrow, phrase, 3 row 3 column grid, group, changed, red heart. Left arrow, phrase, changed, cross mark. Changed, red heart. Down arrow, phrase, changed. Movie, changed, red heart. Right arrow, phrase, changed, cat. Changed, grinning face. Down arrow, phrase, show / hide grid. Down, right arrow, left arrow, phrase. You are currently, left arrow, right arrow, phrase. Down arrow, phrase, changed, thumbs up. Left arrow, phrase, changed, smiling face holding back tears. Right arrow, phrase, changed, grinning face with starry eyes, spin animation.
And so here we get a translation, essentially a live transcription of what's happening on the stage so that anybody that isn't sighted can still experience what's happening on screen. And then lastly, timing and animation are configurable too. And so here we have this little catch the mouse game with a mouse. And let's say somebody is sighted, but has motor tremors and can't very precisely catch the mouse at this current speed. We could slow down animation here and make it so that they can play the game at a slightly slower pace and calibrate the challenge to the level of their abilities. And so this raises lots of questions about accessibility, like what trade-offs does accessible hybrid editors pose to complexity and scalability and error proneness? And how do we make students learn about accessibility in the process of writing programs too, just like they might learn about localization? And what are other forms of input and output that are possible, like speech input, tactile output? All of these things should be explored to really include everyone. Is this justice? Well, only in the most prosaic sense. It's a bare minimum of access, opening up input and output and code to more abilities, and yet not all of them. So true disability justice here would mean not only having all of these features be standard for all programming languages, but having disabled communities lead the design of this platform and its abilities. And we're still really far from that. Okay, one last area to talk about, and that's simplicity and reducing complexity as an analog. And so the key challenge here is that understanding and debugging code has always been a central difficulty in software development. And much of that stems from language features, things like mutability and a lack of tool support for debugging. And all of these exacerbate things like language barriers and accessibility barriers. And again, none of this is an accident. Computing has really long prized performance over program comprehensibility. Every time we make something faster, we make it harder to understand. And that's really a broader project of capitalism. It's about burdening programmers with the cognitive labor to make programs faster. And in educational contexts, this is deeply problematic because it places learners in the same bind as professional software developers, having to worry about efficiency and the complexity that comes with it, rather than just focusing on learning. So the idea here from a justice perspective is to sort of resist that capitalist move and liberate learners from having to really take on those cognitive burdens of understanding programs at the expense of speed. And so here in Wordplay, we do this by doing lots of things. We chose pure functions and immutable data and something we're calling stream-based reactions, all in an attempt to try to simplify program comprehension, to remove complexity. And so I'm going to illustrate a couple of these features. So one is that this notion of streams. This comes out of earlier work in functional programming on functional reactive programming. And the idea here is that every program is essentially a recurrence relation on a time-streamed input. So here, for example, we're typing a program that's just time, and the program is reevaluating as time streams update. And we can modify that stream in different ways and visualize that time stream data using this program. And so that simple idea of having a series of inputs be something that causes program reevaluation allows for many different types of interactivity and visualization. But program evaluation is just function evaluation. And so we can do things like make debugging a simple matter of showing expressions being rewritten as values. And so here there's a simple function that generates a random greeting from a list of different greetings in different languages. And we concatenate these 3 random choices below. And as we step through the program, we can see what choices are being made for each of those function calls and how the program is ultimately evaluating to one final string expression that combines multiple different greetings in English, Korean, and let's see what the last one it is that it chooses. All right. And so this is basically a way of showing how programs evaluate in context without having to have a separate type of debugging tool. But program output, of course, is just a time series of values, and we can recreate any program state from that history of values. And so we can do time travel really trivially in this particular paradigm. So here we've got a cat that's going to catch this letter O that's bouncing around. But if we wanted to debug this, we can just pause the program and then go back to the point in time where the cat intersected with the letter O. So here we'll start the program, the cat hits the O and bounces a few times. We're just going to pause. And then we're going to use this slider and drag back until the ball hits the cat. And we can see exactly what was evaluating at that time. And we can even go through parts of the program and step forwards and backwards in reverse to get precise steps, or choose an expression and just find all of the times that that expression evaluated in the history too, and jump arbitrarily between them. This allows for really fine-grained and really quick localization of exactly what was happening when a program evaluated, because we have a completely deterministic, reproducible history of all of the input that happened to cause the program to run. One last example is all of this allows us to have value provenance, to know the relationship between values and the expressions that created them. And that allows us to do things like bidirectional editing. So here we have a little piece of text on the screen, and there's some code that generates that text and has some styling for it. But we can actually directly select that text and go into a palette and modify it and regenerate code to modify its appearance as well. So modifying code or using graphical user interfaces to modify it, and then generating code and doing program synthesis to modify it in ways that match those desired outputs becomes really trivial in this particular language paradigm. And so all of these questions about complexity are really challenging. Things like, is the lack of mutable state in functional programming an inherent difficulty? Or is it just a property of poor tooling and a lack of interactivity in classic functional languages that make it seem hard, but it's not actually hard? How does the ability to manipulate time change difficulties in debugging? Does it actually simplify things? And does stream input add complexity relative to stateful event-based kinds of interaction paradigms? Or does it reduce it by taking away complexity and making things deterministic? And then, of course, our same question as before, is this justice? Well, hardly. Making program evaluation comprehensible by making time malleable, it's really the smallest form of liberation from efficiency that you can imagine. And it doesn't really change the broader systems. It's an equitable refuge surrounded by inescapable forces of labor exploitation. And so a broader goal might be a kind of economic justice, where programming languages are tools of liberation and creativity and community and a source of empowerment rather than just a source of profit. And so if we step back and think about what it is, this language that I made, this strange language, it's a lot of different things. It's a purely functional, stream-based reactive programming language to a PL researcher. It's also a new medium for creating interactive, multilingual, accessible typographic media, if you think about it more from an expressive perspective. If you think about it from a narrative perspective, it's a fantasy world in which characters collaborate with people and resolve conflicts to create typographic performances. But it's also a cultural mashup of language, typography, interactivity, and logic as a piece of art. And then from a justice perspective, it's a small form of resistance to the overwhelming domination of computing culture in society. So let's return to that story that I shared at the beginning. Is all of this enough to support the teacher and the students that I mentioned earlier? Not really. A platform is one piece of trying to make those classrooms possible. But we also need things like teacher education, curriculum, community, and more to make those classrooms work. A tool alone will not do that work. But it wouldn't be justice either, right? Justice is more than just a better tool and some missing resources. It's also agency and power over the future of computing. And probably the biggest failure of this project is that I created it alone on behalf of others. I did not do that in partnership with teachers and students who are multilingual with disabilities who had their own visions about what was needed and what was required to make those classrooms work. And simply my worldview and my understanding of those things projected onto others' needs, and it could be entirely wrong. And so justice also means sharing power. Having programming language designs be community-led rather than led by me. And so that's what we're trying to do next. I've just begun to attempt this, and I've started an open source community that currently has about 120 undergraduates from around Puget Sound at the University of Washington and other two-year colleges. Many have disabilities, many are multilingual English learners, many are allies of those communities, and we've begun to explore how to structure power in this open source project around the needs and values and dreams of youth who it serves. And so as an example, 3 of the students in this open source community are Somali refugees, and the 3 of them came together and decided that they wanted to write a Somali translation for Wordplay, and in the process have not only translated from English to Somali, but have started to re-examine the concepts themselves in the programming language and the tensions between Somali representations of mathematics and logic and the kinds of Western representations of mathematics and logic in the programming language. So we may change the language semantics in response to some of their ideas to make space for Somali culture in the language. So here's what I've learned so far from a lot of these experiences that makes this challenging. Many youth, they fear the responsibility of holding that power to shape this language. And sometimes they devalue their own expertise of their lived experiences, and they'll defer to my authority as the big fancy professor. So getting them to really own that power and take that agency is challenging. Many of the youth also can't imagine a world that was designed around them. And instead, they imagine that this is a world they have to adapt themselves to. And so they struggle to envision more radical futures where their needs are fully met, and instead settle for a future in which they change themselves to meet whatever the world currently is. There are some youth, however, that in contrast to the above, really are inspired by that radical futurism and are more engaged in making a new world than succumbing to the one that we have. And they're the ones that are, I think, my closest partners in this project. They're the youth that I want to empower to lead this work and that I want to give power to, so we can help start to imagine what platforms like this should be to better serve everyone. All of this, of course, is just the beginning. Here's a picture of a glacier, and Wordplay is this tiny little point that's visible at the top now. And I think I like to end with this quote from Martin Luther King Jr., one that's less known. We must learn that passively to accept an unjust system is to cooperate with that system, and thereby to become a participant in its evil. I am not saying that all programming languages researchers or computer scientists are evil, but I am saying that categorically excluding massive populations of humanity from computer science is in itself evil, and that we should do our best to try to work towards a future where we stop doing that. I'd be happy to take any questions. You can see Wordplay live at wordplay.dev. If you want to contribute as a contributor, it's an open community. We'd also love donations if you want to help pay the rent and tuition of our student leaders so that some of them can stop working at Chipotle and work on this instead. Thank you.
Wow. Wow. Sorry. Okay. Oh.
Okay, there we go. It's on. Yeah. Okay. Oh yeah. Sorry.
Okay. Qu'est-ce que je fais là?
I think if everyone else mutes, you'll be good.
Okay. Microphone. My speaker is off.
Yay, hybrid.
Hafed, you're muted. I don't know if Amy maybe mutes as well. Let's just do a test if that's it.
If I've unmuted myself now. Is it okay now? Is there an echo now for everyone? Okay, it seems to be okay now from mine.
From your
Yeah.
copy.
So, can you hear me now?
Yeah.
Okay, good. So, I said a very interesting thing. I said, wow. So that's the only thing you missed. All right. It will take us quite a bit of time to digest this. I have a couple of comments, but I'd like to take questions from the audience. So I don't know if anybody has any questions. Too overwhelming, yes, that's what I heard. I don't know if we have questions from the people who are online. I can tell you that you have the biggest audience we have had, I think, in the past 3 or 4 years. So there are 20-some people over online, and then about 30 people in the room. So any questions? Have you had anybody has had time to digest some of this?
Or pizza.
Or not? So, vas-y.
So the question is, what is your long-term view? Is it to make programming very just and equitable, and meaning everyone will program will do programming using their culture, language, etc. And would that close a bit the opportunities, or make the opportunities for people to move and exchange less probably possible? I don't know. It's just very very unsure. I'm not certain about my question, but I just read something saying, if programming becomes more accessible to anyone, tomorrow we will all lose our jobs. This kind of thing. So these are, so I don't know What are your comments on that?
Sure, let's start with that one. Justice is not a fixed concept. It's something that is socially negotiated. It's something where we collectively come together to decide what future we want. And I would say that true justice is one in which everybody gets to participate in that conversation. And at the moment, we have a world where computing has largely dominated the world, dominated commerce, dominated information and communication, and increasingly is dominating even our sense of what it means to be human with things like generative AI and our fears about being replaced. So it is hard to imagine a future in which computing only gets to be decided by the 30 million software developers in the world, making decisions on behalf of the 9 to 10 billion people on the planet. So I think my vision at a really high level is what would it look like for the 9 billion people on the planet to participate in shaping the future of computing? And that can't happen if we don't have learning contexts in schools where everyone gets to learn about computing. And that can't happen if we don't have media, programming languages, and platforms that exclude huge populations of people from even learning about computing. And so I think that's my vision, is that we have to start there. We have to think about literacy in a universal sense and have the arguments about what that literacy is and create the infrastructure and tools to make that literacy possible. And then we can have a global conversation about what rights we should all have around computing, what access we should have to it, what regulations corporations should be subject to, and so on. So I think that's one way of thinking through it.
Thank you very much. Other questions or from online land? Oh, yes, go ahead. Yeah, please.
So I guess I had a question about generative AI, and I'm wondering if you see that maybe in the future, as people are learning programming, there will be more focus on prompt engineering rather than learning syntax. And so maybe I wonder if you explored like justice in terms of prompt engineering. Like so far it's English, and it's very kind of dry, not playful, like some of the examples that you've given.
Yeah, let's talk about large language models and prompts and programming. There's been a couple of years of research on this now, and many more years on just the general challenges of program synthesis, not necessarily using large language models. And what we know from a lot of that research is that when you go from a completely developer-driven process of programming and you shift it to a partnership between a programmer and some kind of tool like a large language model or some formal method-based program synthesis engine, it changes what programming is, and not always in good ways. And here's it sort of bifurcates it into two different experiences. When the engine that generates code for you does things that you want and need, and it does them correctly, it can be wonderful and glorious and a successfully productive partnership. When it does not, it becomes much harder than it was before, because you have to understand what was wrong about what was generated, and you have to fix it. And doing iterative prompt engineering or doing more examples to a formal methods-based synthesis engine, it's not always a direct path to getting the program that you want through it. And you don't really know whether or not it's ever going to generate the thing that you want. And so sometimes you have to revert to that former process of just doing purely human-based programming. And so the biggest challenge for both of those is that you've got one great outcome, one not so great outcome, and you never know for any given problem which of those is it going to be. So I wouldn't say that it's a particularly promising approach at the moment, just because you can't predict what quality is. And I don't know that we should necessarily fully invest in a vision of the future where that is always what we're doing. We should examine it more and really understand what those trade-offs are. And then all of that is problematic even more in education contexts where prompt engineering and iteration doesn't work at all if somebody doesn't actually understand the language, syntax, or semantics, because then they can't actually reason about what the program is doing and know whether it's right or wrong. And so they just take it on faith that it's correct and end up not understanding computation.
Excellent. Thank you very much. Great. Kim, go ahead.
Yes, hello, Kim Lava. I'm a clinical psychologist working in health, and it was a fantastic talk. Thank you so much for taking the time to speak to us today. My question is more about how do we really move this forward, and what do you see as sort of the main barriers for this being internationally accepted as the default practice? I agree with you. I mean, everything's dominated by the colonial winners, so to speak, historically. And there's going to be, I don't want to be the psychologist who's sort of the pessimist, but people are notoriously resistant to change. People don't like to do things differently because it requires effort and it brings uncertainty. So how are we going to, what do you see as the major barriers to getting all the haves to embrace this as what should be the default method?
Yeah, that's a great question. And I'm often playing that role of pessimist too, just because when you face reality, it's really hard to see hope for it too. But let's talk about some of the concrete things and what we might do about them, the concrete challenges. Here is one. I've been eagerly pursuing partner teachers in schools in my region, especially ones in South Puget Sound in Seattle. Most of the teachers who have capacity are ones at private schools that have lower teaching loads, and students who have more flexibility in what they're teaching and learning. The teachers in the schools that are lower resourced, that have this diversity of students, they don't have time to partner. The only way that I've been able to get time for them is to ask for money from the National Science Foundation to essentially pay their full salary over the summertime. To give them 3 months of time to do course prep around this and partner around this. And so that's been one solution that I've looked at. And ultimately, it's just down to resources, right? It costs money to make time to do this work. Students, same thing. Students do have a lot more time in some cases. And you don't have to pay them as much to participate, but paying them something matters. A lot of the students who I wanted to participate, they're busy working part-time jobs at 16, 17 to support their families. And so paying them to do this instead is really the only way that we can make sure that their voices are leading these projects and this work. If we don't do those efforts to make them at the center of this work, we will fail. We'll produce things that aren't needed, that don't work. And so I think that's the core challenge, is convincing the world that paying for people to create that better future is something that's worth investing in.
Do you see barriers from let's say a commercial perspective in terms of, what's the pushback going to be at that level?
Yeah, absolutely. I mean, it's not in corporate interests at all to imagine a different future, because the future that they want is the one that they have right now, which is where they have the power and the resources. So yeah, there's structural issues about that too, and the IP. And so this is just true for every project of justice, though. Like, you just end up having to fight for years for small wins, and then sometimes you lose things. And I just think that our work as computer scientists and others who are thinking about the broader impacts of computing on society, we just have to make a moral decision about whether or not we want to be doing that work or work that reinforces that status quo.
Great, thank you.
Excellent. We had questions actually from on the chat, but one of the people asking the question is in the room, Max. And he's a junior colleague who will join us in a couple of months.
Thank you very much for this talk. I really appreciate it. I had most of it on the bus because I was a bit late. But it seems the education sector is the perfect place to start, right? Because if you render education accessible, that's how you can transform things. But we also have a bit, I feel, about software things take place in industry places, so to speak, the antagonist or colonialism. So I was wondering what would be your take, and how can we improve software engineering as it takes place or right now in industry to make it fairer and more accessible and maybe lower barriers? What are your ideas or the first step?
Yeah. Yeah, that's a great question. And it's an interesting time to ask it too, because over the past several years, there have been a huge number of people in computer science and software engineers in industry who have given a lot of their time, volunteered a lot of their time to try to make different specific programming languages better. Like take Rust, for example, and all of the effort that's gone into Rust over the past few years from the community. Where has that effort gone? It's largely gone into things like type safety, speed. It has not gone into things like making Rust more accessible, for example, or making Rust more language inclusive. It's a simple matter for all of those individuals and the collective to say, we should also put time into those other things and not into performance and not into more precision in the type system for the language, for example. And that's the challenge, is that the people with the skills and capacity to do that work, they're putting their time into those classic concerns in computer science as opposed to these justice-centered concerns. So I view that as a chicken and egg problem. The people with the skills don't want to spend time working on accessibility and language inclusion. And the people who need accessibility and language inclusion to be there, to even participate in developing Rust, they don't have the skills yet because they can't participate in computer science education because our education systems are not inclusive in those ways. So that's the thing that we have to disentangle before any of that work becomes possible.
Thank you very much. Other questions?
From Amanda on the chat.
Oh, yeah. Amanda, do you want to ask your question vocally? If you're still
Hello,
here.
can you hear me?
Yes, we can.
Can you hear me? Okay, sure. Yes, I can ask my question vocally. So, it was a super interesting talk. I really love like what you're trying to do. Inclusivity is so important. My question was more on like the process of developing your language. So I'm really curious to see like, did you have the opportunity to get feedback from children or users while you were creating this? You know, through the different stages of development, like what were some of the key things that you've noticed while like building this kind of thing? And
Yeah.
what were some of the aspects that they appreciated the most that they like expressed to you like directly? Like what did they like about it?
Yeah, that's a really great question. And one of the big tensions about this project, because what I needed over sabbatical was just a little bit of quiet creative time. And so that's what I used this for. And so I didn't spend a lot of time talking to youth or talking to teachers or building that community while I was building this beta version. I'm doing that now. And so that's work that I wanted to do after sabbatical. So let's talk about why I thought that was reasonable. So one is that I've spent 20 years of my career studying programming, talking to youth, talking to teachers, talking to developers. And so I felt like I had a lot of knowledge going in about how the systems needed to work and what would be usable and wanted. So I wasn't starting from no knowledge. And I've spent a lot of time in middle school classrooms and know a lot of different youth who speak a lot of different languages. So I was taking that knowledge and using it in my design process. Now that I'm engaging with communities more directly around it, the central questions that I've had around it are how to structure our design process so that they have power in shaping our design priorities and our design decisions. And that's something that most programming languages and certainly educational programming languages have not done. Usually there are some lead designers that retain the control over what the language is, what the design choices are. And I think a big open research question that I have is, how do I structure that design process so that I don't have that power and that a student advisory council, for example, has that power, where they feel empowered to really say, this is where the next version of the platform needs to go. These are the features that we should prioritize. We should change this design choice and replace it with something else. And I don't yet know how to create that context where they feel courageous in their ability to make those proposals. That's what I want to build next.
Thank you for your answer. That was really interesting, and I think that like what you just said, like you don't know what the next step is. Like I think in my perspective, like community, like trying to build a community with those people, like where they can feel recognized and like, you know, visually like seen as important would be like the very first step to like to knowing what to do next, because they'll
That
feel
is-
empowered from having similar people, you know, in that space that, you know. So thank you very much.
Completely agree.
Thank you very much. I do have a couple of questions, but I want to give priority to the questions from the audience. Okay, so let me be the nerd. I love the idea of localization. Like, how come we didn't think of it earlier? That sounds like an easy enough thing to do, and I think it's very valuable. The question of playfulness, and you did mention it, is how far can you go with this? I remember teaching or trying to teach my son learn Scratch. So they teach Scratch in his in I think it was early high school. Of course, being a computer scientist, the trouble I had with it is there's only so far I can go with him using Scratch. There will get to a point where the more complicated concepts, where the anthropomorphism becomes a limitation. And so there is the risk of that becoming a sort of a ghetto in and of itself. So people who learn with the anthropomorphic way can actually get stuck and not be able to progress. So what's your take on that?
I think that I would ask another question about that, which is who gets to decide what real programming is? Why are our professional languages the ones that get labeled as the legitimate ones, the valid ones, the real ones? Why would we devalue platforms and languages that present computation in different ways? And I think this goes back to a point I made in a different talk a couple years ago, which is we need space. We need a world where there are just 100 different kinds of computing cultures, 100 different kinds of computing platforms, all valid in different ways, serving different communities, serving different purposes. And in a sense, that's what we have now to an extent, right? Scratch is a place where that is true. For millions of youth, they view that as a legitimate place for them to express their creativity through computation. What we also have, though, is a judgment of that community, that it's not actually real or that it's not valid, and that the only valid endpoint is that they eventually leave it and go somewhere else and do something that's more valid or more serious or more supported. So I think that's just a question that we have to answer. You know, what does it mean to have a big diverse ecosystem of places for computation, and how do we validate all of them?
Okay. Fair enough.
May not be satisfying, but like, yeah, people build all kinds of practical, useful tools in all kinds of educational programming languages, never go to any other language and live with that form of computation for their whole life and get value from it. So we have to just reckon with that reality, right? That they don't have to leave.
Right. My next point is actually more of a comment. I attended maybe 34 years ago a keynote given by Bill Buxton, who's your academic grandfather, if I understand correctly.
Yeah.
Okay. About user interfaces, and it was at UPSLA. I think it was UPSLA 1990. So most of the people in this room were either, and you included, were either in elementary or high school or not born yet. But anyway, it was a fascinating talk. And he was talking about how limited we are in our view of how we interact with a computer. And he showed that there are ways, much more powerful ways and much more refined ways that we can interact with the computer as opposed to just with the mouse and the keyboard. And one of the demos he showed is a lady playing an electronic harp. So it's actually, there are no chords, there are no real physical chords, but the lady just positioning her fingers in the space between two bars, and she was playing notes like that. And so the point was, well, she doesn't need chords, she doesn't need keyboard, she can play harp. My feeling was, yeah, but that's got to be very, very difficult to do. So I mean, in terms of accessibility, yes, you can do it without the discrete interface elements, but my goodness, how many hours of practice?
Yeah. Yeah, and accessibility, I think, is a really fascinating space to think about programming and computation too, because we really haven't put a lot of time into creatively imagining all of the possible ways that we might write and read code. We put a lot of time into doing it with keyboards and, you know, a little bit more time with a mouse. But what would a really rich and productive speech-based programming environment look like? There have been a few research projects over the past couple of decades to try to examine really basic support for that. But what would really, really good support look like for that? Why don't we have entire research projects that are imagining that? Or why can't we feel code with our fingers for people who are blind and read Braille, for example? What are all the rich tactile interfaces for understanding computation? It's just that we haven't examined that and explored that. And we can't imagine what might be possible in that. The last thing I'll say about accessibility is that over and over and over again, every time we invent access technologies that have some other way of engaging with computing, we find that it's not only people with disabilities who benefit, but it's everybody who benefits. Captioning, for example, like we have on in Zoom right now, captioning was invented explicitly for deaf and hard of hearing people, but here we are using it for a multilingual space. We're using it for attention. We're using it for other reasons other than accessibility too. So I think that investing in those things can really open up possibilities for everyone, not just people with disabilities.
Great. Are there any other questions? Yes, go ahead.
Thank you for presentation. It was beautiful. I really tried your wordplay last night, and it was hard to code in there, even for me as a computer scientist. But my question is, did you ever thought about using motor imagery classification for accessibility instead of voices and this kind of stuff?
Oh yeah, I mean, this is very much a beta. There's all kinds of different possibilities for accessibility. And I think we want to explore all of them. It's really a capacity question. Can I get PhD students and undergraduates and high school students and teachers to help shape those ideas and really understand what's needed and wanted? And I think that's why this is a very long-term project. It'll be something that we explore over the course of many, many years. But that's one good idea. File an issue on that one. I don't think we have an issue to represent that yet.
Other questions, comments? Just a little joke. I like the committee, the language designed by committee. Ada was the last language that was designed by committee. So I just leave you with that thought. So.
And that's a real challenge here, right? Having
Yes.
having a community of youth design this, if you've ever designed a programming language, sounds like a disaster. And yet, if we don't do that and we don't have their voice in it, it will also be a failure. And so I think that's the interesting research question.
Excellent. So if there are no other questions, thank you very, 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 very much. This was a very enlightening and very thought-provoking talk. And I'm really happy that Ghazlan and I did not give up on you, and we kept chasing you for this talk. It was worth all the effort, and thank you very much for this talk. It was great.
Yeah, thank you so much for the invitation and your attention. Bye.
Oops, can you see my fingers? All right. Thank you, Amy.
Thank you. Bye.
va difficilement faire mieux, hein? Ça va.